Hi everyone, I'm happy to be back to you again. I hope your day is going well. Okay, we are all done with chapters 1 to 3. Today we are going into chapter 4, data presentation, analysis and discussion. By now we've gotten all our samples, we've done all our work with all our methods and everything. We now have all our data ready. So we are going into the presentation and analysis of the data for discussion. Introduction. This comes up usually in chapter 4 of the research project. Chapter 3, remember, is a methodology. So this is chapter 4, where you talk about your data presentation. So it comes up in chapter 4 of the research project. This is where the researcher presents the data collected from the respondents, though not in the raw form. The researcher presents the data, all the data you collected from your respondents. That is when it comes to questionnaire, all the data you've collected from all your respondents. And then if it's for the scientific ones, the data, the samples you've collected from your different environments, all the samples you've collected and you've worked on them, the data you have from them. Now, it is not in the raw form. By now, you would have put them together, just organize everything together. That's what it means that it is not in the raw form. You know, your questionnaire, you get views from different people. You get from Mr. A, Mr. B, Mr. C. Just get everything together in the raw form. And then you will now compile and arrange them in order. So it is not done in the raw form. In the raw forms, it is quite difficult to present and analyze data. When you're analyzing it, you don't have to do it if it's in that raw form. This person, Mr. A, said so things, filled your form in this way. Mr. B did this, Mr. C did this. For all your respondents, you know you're going to have a lot of respondents. And then by the time you bring them all together, you cannot analyze that data in that form. So you have to put it in order. In the raw forms, it is quite difficult to present and analyze data, which is why there is a need for the raw data to be organized and presented in more compact form. So you have to organize it first. Gather all your data together and organize them and present them very well. Okay, subjecting the data to tabulation, grouping, or even graphic forms so as to allow for easy handling and analysis to do this. So you can use tabulation when you put them in a tabular form. You can group them. You can even use graphs to show them so that once somebody looks at them, it will be easy to understand. In doing this, the chapter sets out on an introductory note, often referred to as preamble, where the researcher provides useful background information on the respondents group or groups, their characteristics with respect to their biodata, and the state of returns of the data gathering instrument. So these are the things the researcher has to provide first. It's called a preamble. You provide all this data, the information about your respondents, their characteristics and everything. Just tell us something about them before you go into the presentation. Okay. After this, he moves on to the main theme of his research by presenting necessary data in the forms considered most appropriate for the purpose of analysis. So you decide on the one that is most appropriate to you, whether it's going to be in a tabular form or in a graphical form or otherwise. Okay, if, as an instance, the tabular mode of data of data presentation was used. The tables should be well titled. Yes, if you're making use of a table, if you want to present it in a tabular form, you title the table very well. The table, you're telling us what is the title, what is the data in the table talking about. So the title will be a kind of guide to what is expected from the table, each followed by detailed explanation on the data presented. So when you give the title of the table, you give a detailed explanation of the data you're presenting on the table. All this will help to understand your presentation better. This pattern should be used for each of the tables presented. So no matter the number of tables you want to present, each table must have this. You must give us the title of each table, and you must give us a detailed explanation of the data you're presenting on the table, no matter the number of tables you're going to use. Also important other data analysis is the discussion of results segments. When you present the results, you have to, of course, discuss it before you finally arrive at your conclusion. This comes up normally after the entire presentation exercise had been concluded. When you finish all your presentation in the form of tables, graph, or whatever, after the presentation, you begin to discuss the results. The discussion is what you have presented as your result. It is the segment where the researcher gives a more detailed insight into the issues directly relating to the data presentation and analysis. So it gives more insight on the result. Okay, the segment helps to articulate the issues emanating from the data analysis with respect to whatever implications they have on the subject of investigation. If the study is concerned with hypothesis testing, it is in this segment that the implications of the outcomes of the test as they relate to the subject of research will be explained. So it is on this session now, after getting your data, it is on this session that the implications of the outcomes of your result, of your work, will be explained. You have to explain everything, because at the end it's going to affect your conclusion. Here also, conclusions on the relationship of the outcomes of the present study with previous ones are drawn. Remember, somebody may have worked on what you're doing, so you have to relate your result to the result of the former researcher. So conclusions on the relationship of the outcomes of the present study with previous ones are drawn. Take, for instance, you're working on effects of drugs on youth. Somebody else may have done it before and gotten his results. Now, your own results, there has to be a difference between your results and the previous results that have been gotten. And then you will not be able to relate the two of them and find out the reason for your own difference. Whether it's the effects on the environment or whatever it is, it's all contained in your discussion. So here also, conclusions on the relationship of the outcomes of the present study with previous ones are drawn, with a view to establishing a link between the outcomes of the present study and those of previous studies as already established under the literature review. So there has to be a link. You tell us why yours is the extra thing you have gotten in the course of your research as related to the other research that has been done. Furthermore, the researcher dedicates a part of this segment to interpretation of the outcomes of his findings, thereby giving more meaning and sense to the data analysis exercise. Right. The use of statistics in data analysis. Sulaiman, 1997, defined the term statistics as a branch of applied mathematics which is employed in analysis of data to facilitate meaningful decision making So statistics is actually, statistics is also calculation. Mathematics is calculation. So statistics is a branch of mathematics. It's a branch of applied mathematics. It's used to analyze your data. Once you're working with data, you need statistics. The statistics helps you to analyze your data and facilitate the meaning. It helps you to analyze your data to facilitate meaningful decision making. Sulaiman in 1997 defined the term statistics as a branch of applied mathematics which is employed in analysis of data to facilitate meaningful decision making. So it helps you for decision making. It helps you in your decision making. It is also described as the theory and methods of analysis obtained from samples of observation in order to compare data from different empirical observations using hypothesized relationships in order to make meaningful decisions. Even then, the methods of data analysis depend on the aims and objectives of the study and the nature of the data gathered. It becomes clear from the above that statistical analysis could be useful for reducing quantities of data to manageable and understandable form. Now, when you analyze your work, it reduces the quantities to manageable and understandable form. Take for instance your table. You have different data from different sources all scattered around. You will not be able to manage it properly until you compile them and put them together. So when you put it in form of a table, it reduces the quantity of data. All your data will still be there, but in a reduced quantity, and it will help you to manage and really understand it very well. It aids in decision making. When you look at your presentation, whether in a form of table or graph, it helps to take decision. It summarizes samples from which they are calculated, and it aids reliable references and decisions from hypotheses. Alright, let's take it again because we need to put it down. Sulaiman defined the term statistics as a branch of applied mathematics which is employed in analysis of data to facilitate meaningful decision making. So it helps you to facilitate your decision making. It is also described as the theory and methods of analysis. It is also described as the theory and methods of analysis obtained from samples of observation in order to compare data from different empirical observations using hypothesized relationships in order to make meaningful decisions. Even then, the methods of data analysis depend on the aims and objectives of the study and the nature of data gathered. So depending on the particular study you're working on, your aims and objective, the methods of analysis you will use will be dependent on your aims and objectives. It becomes clear from the above that statistical analysis could be useful for, let's take it down, use of statistical analysis. One, it reduces quantities of data to manageable and understandable form. Reduce quantity of data to manageable and understandable form. It aids decision making. 2. It aids decision making. 3. Summarizing samples from which they are calculated. That's the samples you have gotten. It gives a kind of summary. You have a lot of samples that you have gathered. It gives a kind of summary of the samples. So it summarizes samples from which they are calculated. From which they are calculated. Then the next one is 8 reliable references and decisions from hypothesis. Alright, so statistics thus serves as a tool used in collecting, organizing, analyzing, and interpreting data. So you see how important statistics is in your research project. Without statistics, you cannot analyze your data. It helps in collecting, organizing, analyzing, and interpreting. It is when you're able to organize your data that you can analyze it. And when you analyze, you'll be able to interpret your data. Generally speaking, statistical methods are categorized into broad classes of descriptive and inferential statistics. Descriptive and inferential. Okay. Classes of statistical methods. We have 1, descriptive, and 2, inferential. Okay. Alright, descriptive statistics are often used to summarize the data collected. You use descriptive to summarize your data. You state facts. It helps to state facts from the summary of your data. While inferential statistics are used to determine the generalizability of findings arrived at through the analysis of a sample to a larger population. So when you're talking of inferential, you're talking about making predictions. It helps to make predictions kind of about a larger population. Descriptive takes facts from your summary. It helps you to summarize your data. But when it comes to inferential, it helps you to analyze. It talks about the larger population. It analyzes the larger population, and it helps you to be able to make predictions about that particular population. Note that descriptive statistics can be used for both sample and population data, but cannot be used to perform inferential tests on population data. This is because the results obtained from descriptive analysis are definite enough for the population of interest. The application of either descriptive or inferential statistics to a set of data largely depends on the levels or scales of measurement of underlying variables. Okay, In all, there are 4 levels of measurements, otherwise known as scale. 4 levels of measurements. Levels of measurements of variables. Levels of measurement of variables. The first one is nominal scale. You have the ordinal scale, the interval scale, and the ratio scale. Let's take it one after the other. Okay, brief discussion on these 4 levels of measurement will contribute to better understanding of the uses of statistical methods and data analysis, hence the following. So we take them one after the other. We have nominal scale. Nominal scale. Number 1. Nominal scale. This is considered as the simplest and the least refined scale of measurement. Even though it's the simplest, it's the least refined, it's the least of all. One whose primary use is to provide a labeling function. A good example of this is the individual sex, which can be either male or female. There cannot be any other thing between these two. The yes or no kinds of questions are also good examples of this. However, it lacks the property of order and magnitude. You see why it's called the simplest and least refined. It's least refined. It's always a yes or no answer. Is either this or that. Either take for instance for this sex now, is either you're a male or a female. Nobody's a hermaphrodite. Is either you're a male or you're a female. So is either M or F. Either yes or no. There is none is greater than the other. Is in terms of there's nothing like measurement or weighing or something like that. It's either you're this or you're that. So that's why it's called the least refined. When we get to the other ones, you find out that it's actually the least refined and the simplest. Okay, the next one is ordinal scale. Ordinal scale. Ordinal scale. This kind of measurement also performs the labeling function apart from its ordering form. This is because it possesses the property of order and magnitude. Order and magnitude, such that two things could be compared in terms of their relative magnitude. When you compare two things in terms of their magnitude, a good example of the ordinal scale relates to the degree of agreement with a statement, such as strongly agree, agree, disagree, and strongly disagree. So you see the difference between this and nominal scale. Yes, it's either you agree or you do not agree. But in this case, it has an order and magnitude. To what extent do you agree? To what extent do you disagree? It's talking about the magnitude of your your decision. Do you just agree, or you strongly agree, or do you just disagree, or you strongly disagree? Using this scale to measure two units, one will be able to determine which is higher or lower, and not just that they are not the same. You can see that somebody may just agree with something just like that, but another person will strongly agree. That is, there is nothing that can make me to disagree with this. I strongly, no matter what, I strongly agree to this. So that's the magnitude. You can see the difference between the two people. This one just agrees, okay, I agree, fine, I agree. But this one strongly agrees to it. So it is that order and magnitude that differentiates it from the nominal scale. Nominal can just be agree, not agree, yes, no, male, female. Okay, now ordinal can also be rated. Ordinal can be rated. You can say, okay, strongly agree, we have a rating of 3. If you strongly agree, you rate 3. If you agree, 2. If you disagree, 1. And if you strongly disagree, 0. Let's rate it. It could be rated. Could be rated thus, e.g. strongly agree, having a rating of 3. This is just an instance. Agree, having a rating of 2. Disagree, having a rating of 1. And then strongly disagree, having a rating of 0. So you can see the difference between strongly agree and strongly disagree. Okay, so using this scale to measure 2 units, one will be able to determine which is higher or lower, and not just that they are not the same, not just that these two are not the same. You'll be able to determine which is higher than the other. Okay, we go to interval scale. Interval scale. That is number 3. Interval scale. Talking of interval, from the name interval, you can see is a kind of distance between this and this. This also has the property of order. It has the property of order, magnitude, and additivity. We are talking of intervals now, additivity. Since equal intervals on the scale represent that there is a difference with a magnitude. There's a difference between this particular point and this particular point, separated by an interval. There's a difference with the magnitude. The scale does not possess absolute 0. It doesn't, because the 0 is arbitrarily set. In addition to its ordering function, this scale can be used to determine the difference between 2 units. It can be used to determine the difference between 2 units. Measuring the temperature of a room in Celsius and Fahrenheit is a good example of this case. In interval scale, the interval between values are always equal. Like we once talked about in our previous lectures, when you have intervals, you can have an interval from 0 to 10, 10 to 20, 20 to 30, and so on. The difference between each 2 points is 10. That is, you're using this 10, 10, 10. So the distance, the intervals are always equal. Distance between 0 to 1, the same as distance between 1 to 2, distance between 2 to 3, and so on. Distance between 0 to 10, the same as distance between 10 to 20, the same as distance between 20 to 30, and so on. Example, your temperature in degrees of Fahrenheit, difference between temperature of 100 and 90, same as difference between 42 and 32. So in interval scale, the distance is always equal. Now the last one is the ratio scale. The ratio scale. The ratio scale. This scale is the highest level of measurement. It's the highest level of measurement. Remember, our nominal scale is the least, the simplest. Our ratio scale is the highest because it has an absolute 0. You can see the difference between the ratio and the interval. In the interval scale, interval does not have an absolute 0, but ratio scale has an absolute 0. Let's look at this ratio scale. This scale is the highest level of measurement because it has an absolute 0. As a general rule, whatever statistical methods are applicable to variable measured in the nominal scale can be applied to those measured in the ordinal and interval or ratio scale. Whatever method is applicable to nominal can also be applicable to ordinal, interval, and ratio. Similarly, those statistical methods applicable to variables measured in ordinal scale can also be applied to those measured in interval and ratio. Are we getting it? The one for nominal can be applied to ordinal, interval, and ratio. The one for ordinal can be applied to interval and ratio. Alright, let's move. There are, however, statistical methods that are applicable to variables measured in interval and ratio that could not be applied to variables measured in the nominal scale. So you can see that you can see the difference now. There are some methods, in as much as that all the ones in nominal can be applied to interval and ratio. There are some that are applicable to this interval and ratio method that are not applicable to nominal scale. Some examples of the ratio scale include weight, time, speed, thus possessing all the properties of the other scales. So if you look at weight now, weight can possess the properties of nominal, ordinal, interval, and ratio. Now, you see why we said that ratio has absolute 0. If you look at this weight now, for example, measurement of weight, there is no weight you measure that will be less than 0. No weight at all. No matter how light the weight is, it can never be less than 0. So the ratio now, ratio as interval, ratio is the same as interval, except that this ratio has an absolute 0. They're just the same, the ratio scale and the interval scale. If you look at the two of them, but the only difference is that Whereas the interval scale does not have absolute zero, ratio has absolute zero. Like this weight we've talked about now, no matter how light a weight is, it can never be below. You don't even have a weight that is zero, to talk of being below zero. So you can never have a weight that is less than zero. So if we look at all those scales now, you can see the relationships they have with one another and the differences too. Your nominal scale, your ordinal scale, your interval scale, and your ratio scale. Okay, let's do a brief introduction to this next one. Like I told you, I want to take this latter part of it gradually, especially as we are heading towards the calculating aspect of this. It's not something you rush into. It is something you take gradually and you understand it very well. The next one is procedure and tools for data analysis. Procedure and tools. In data analysis, there are procedures and tools to be employed depending on the type of research as well as the nature of the data to be analyzed. Regardless of the instruments or methods used in data collection and whether the data is from sample or population, the first step in data analysis is to describe the collected data. After collecting your data, you need to do a proper description of that data you collected. To do this, however, the data should be summarized either using a frequency table or chart. These are two veritable tools for presenting and communicating data in such writings as technical reports and journal articles. You talk about your frequency table, your data. When you're collecting data, you collect randomly. Some numbers may occur more than the other numbers. That's where the frequency table comes into place. Frequency table and charts. So the frequency table, there is no doubt that with the frequency table, the researcher can display the number of cases which have each of the attributes of a given variable. It also serves to display both qualitative and quantitative data. When confronted with the number of attributes or categories of a variable that is too large, the frequency table adopts the group data approach by combining the attributes into classes. So depending on the number of depending on the data you have, the quantity of data you have, the frequency table, if it's not much, you can just use the normal frequency table. But when it is so wide, when it is so much, it groups them into classes. E.g., with age as a variable, the frequency table may present data as this. You can have 20 to 24, 25 to 29, 30 to 34, 35 to 39, 40 to 44. You can see that the intervals are always equal. Like your data for age, you can have so many people that are within the range of 20 to 24 years. So instead of calculating them 21, 21, 21, 21, 23, 23, 23, 24, 24, instead of calculating them like that, you group them. You group them. This age from 20 to 24, we have 50 people. You can imagine writing the figures 20, 20, 20, 21, 21, 22, 22, 22 into 50 different places. It will be better you group them together within this range of 20 to 24 years, you have 50. Within the range of 25 to 29 years, you have 30. Within the range of 30 to 34, you have 100. We are still going back to, I just want to introduce you into these frequency and charts. The next class will still go back to it, where I will give you a detailed calculation so that you will understand them better. The charts, just like the frequency tables, there are also charts, which serve similar purposes. The two most commonly used charts are the pie and bar charts. Pie, when you talk about pie, from the name, pie is in a circular form. Then bar, something that is in bars of chocolates that you buy for your kids. Bars that are in form of bars, rectangular form. That is, both could be used to present data summaries and also used to interpret and convey the message more quickly, concisely, and clearly than frequency table. The charts and the bars that are in a picture form. Naturally, when something is in a picture form, it conveys a message more quickly. Well, let's talk about outside researches now. When something is in a picture form, it conveys message more quickly and clearly, rather than just hearing it in figures and all that. When you listen to news, at times the newscaster, they will read out the news, and then you'll be shown a scene of what happened. It helps you to understand what the newscaster is talking about more easily. They'll give you a scene of what happened, the picture, certain pictures and all, videos. When you look at them, it helps you to understand more clearly. Even in children, when you're teaching children in school, at times you use pictures. You show them things that they can visualize, that they can look at. When they look at those things, when they watch it, it sticks more in their memory. It helps them to remember what the teacher has taught, not just calculating figures on the board, telling them verbally and all that. You try to show them pictures. When they see those pictures sticks, and it helps them to learn faster. So pie charts and bar charts, they convey messages more quickly than your frequency table, where you have just figures and figures and figures. Okay. Their great limitation, however, lies in the fact that they hardly cope in situations where the attributes of a variable to display are too many, especially when these are more than 9. Okay, you can look at our frequency table now. We said that in frequency table, when they are so large, you can put them in classes. You can set them in classes. Look at the classes we have here, so that it will help you to organize the data very well. But in the case of pie chart and bar charts, it is not like that. Pie chart, like we said, pie chart is in form of a circle, and the various data, the figures are distributed in form of segments of the circle. So when you have the lower the number of data you have, the better. When you visualize it, you understand what is being talked about very easily. But when the data is so much, the wider the data, the smaller the segment of the circle. And when the segment of the circle becomes so tiny, it will not be easy for you to really understand the message very well. So this great limitation lies in the fact that they hardly cope in situations where attributes are so many, you have so many of them to display. This is particularly for pie charts, which are quite useful in providing vivid picture of data, but not only in showing the distribution of variables with single responses. So in pie charts, when you use pie charts, men looking at it, you'll be able to interpret the result. But when those segments are too tiny, it will be very, very difficult for you. Thus, they are inappropriate tools for variables associated with multiple responses from the units of the study. Also, while they are most applicable for qualitative data, pie charts also serve to display quantitative data, particularly those whose number of attributes or categories is not more than 5. Those ones that are not more than 5. So if you have just like 5 categories, the pie chart is very appropriate for that. As for the bar charts, they serve for qualitative data in particular, irrespective of the nature of the responses to the variables, either single or multiple. Since bar charts make it easier to compare the categories of a variable, they are more suitable for displaying data with more than 5 categories. So bar chart is actually better. They also serve to display quantitative data, particularly the variable presented in a discrete fashion. However, histogram remains the more appropriate tool for displaying continuous variables. Bar chart has a similarity to histogram, but they also have their differences. Histogram is more appropriate for displaying continuous variable. Bar chart is better for discrete variables. That's where, when it comes to variables you can count, those things that you can, like when it comes to counting of objects, bar chart is okay, is for those discrete variables. Well, but when it comes to continuous variables, in terms of measurements, where you need to measure weights and all that, is a continuous variable. In that sense, histogram is more appropriate. Alright, our next class we'll go into measures of central tendency, but like I told you, we'll still go back to this histogram frequency table. We'll start off from frequency table so that we can do serious calculations on this. I would really like you to understand these calculations very well, so that you'll be able to make your own calculations when you're running your research work. So we'll do those calculations on histogram, then we'll come back to measures of central tendency, the mean, the median, the mode, and the rest of them. Alright, so we'll call it a day here. I'm sure you're still getting the whole lecture. Is becoming more and more interesting. I love calculations a lot, and I hope you do too. Thank you so much. Have a wonderful day. Hope to come back to you again. Have a great day. Bye.